All right, in this video, I'm just going to verify a couple more trig identities. And again, at this point, we really don't know a lot as far as our bag of tricks. We know, SOHCAHTOA. We know cosine squared plus sine squared equals 1. And really, that's about all we know. I guess we know cosecant, secant, and cotangent. But again, we don't know a lot yet. All right, so my advice to you is to treat this like a brick wall and focus on the uglier side. You can't work both sides in trig identity, so you pick one side, you work on it. If you make a mistake and pick the wrong side, then you can switch later, but then you have to start over. So I am going to start over here. Just looks a little uglier, mainly because of the denominator. And then I'm going to, kind of see what I can accomplish here. So the first thing I look at is this has two parts over here. This guy only has one. So I probably need to do some math to get rid of that. So I have, I'm going to go back and erase this a little bit so I have more space. So I have this, and I'm like, I kind of want to get it to 1. So what I'm going to do is I'm going to multiply it by 1 plus sine of theta. Right, so right there. And the reason I know that might be a good idea is, first of all, if I can get like a 1 with a sine squared, we have cosine squared plus sine squared sine squared plus cosine squared equals 1, and I can manipulate that to maybe get something good. It's kind of like using the conjugate too, so that these guys are, something good's going to happen here. So you're going to do the distributive property up here. And when you do FOIL, first outside, inside, last here. And that's why I purposely picked that. If you remember, sine squared of theta plus cosine squared of theta equals 1. So let's see, if I subtract sine squared of theta, you can see that this guy can be replaced with cosine squared. Anytime you see squareds, you're going to think of that fundamental trig identity and maybe do something with that. So I can replace this with cosine squared of theta. Now, you can't cancel parts. You can only cancel chunks. So don't be trying to cancel this cosine and stuff. You can't. This is an addition problem. You can only cancel factors. So don't be trying to do that. If you do that, that would be like similar to doing, I don't know, 24 divided by 2 and saying that you could just make that be, I don't know, 4 or 14 or something. You can't do that, all right? You have to have factors to cancel. So like 2 times 12, those are factors divided by 2. Then you could cancel that and make it 1. That's legal. But when you have add-ins or parts to an addition problem, yeah, I can't factor that. So, so let's take out a cosine of theta so we can factor. This factoring method is just taking out a GCF, or greatest common factor. And so what's left is that guy over cosine squared of theta. Now I have chunks of information and a multiplication. So this is a factor as a chunk, and this is a factor as a chunk. So I can factor out and cancel one of those guys, right? And then if you look, that's exactly what I wanted to get. So again, I'm really not using any new things yet. Basically, I used like the conjugate to get rid of that guy, to get it to be a cosine squared. And then I had a binomial where you have 2 parts, and I wanted to factor that, so I took out the greatest common factor. That would be comparable to like, I don't know, 3x plus 9, taking out a 3. That's the greatest common factor of those two. And so you have the GCF and then a binomial, and then we could cancel.